What is OLTP again?
Let me see. Let me look up.
Or OLAP? Oh, analytic processing. Oh, and transaction processing, I think. Yeah. Yeah, so transaction processing is like simpler. And I think didn't they like say they would, yeah, how they'd store the data was all, there was like one main table and every
Yeah, that's what I
attribute
was
was
looking
its
for.
own table or something like that.
Yeah, I was actually trying to find the spot where they said some of the columns in the fact table are
Column oriented
attributes.
storage. Is that it?
Yeah,
Was that it, or
yeah.
was it a different thing?
I think that's what it is. I was
Oh,
trying to
yeah.
read it.
And then I think actually that's, is that because I think normally you would when you're reading,
Mhm.
um you're reading or like they would store an entire record um in disk, so they write like one
Mhm.
record in disk and then the next record in disk and then the next record in disk. So if you're column bounded, if you have like tons of columns, um like analytics where you might have 1,000 parameters or something, then you might have to like you'd have to access all of that data in memory at once versus like column.
Right.
You break them into separate tables and then you're gonna, because I think that's how it is. It's like this is like you're looking and there's some index that's telling you, okay, this is the start of the record, and
Mhm.
then the first part of the record is like saying, okay, there's um like the total record size is 1,000 characters or something.
Right.
So
Yeah, I like it where it says right here. The idea behind column-oriented storage is simple. Don't store all the values from one row together, but store all the values from each column together. I like that.
yeah, yeah, that was really
So it
interesting.
only needs to do like one read, It's cool.
Oh yeah, I guess because they're gonna, because let's say they had to do that on a million records,
Yeah,
they'd have to access all of that data from a million records at once versus,
yeah,
yeah, and they're saying typically you only need 4 or 5. Yeah, that makes sense.
yeah. That's 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 the kind of thing that I'm like really interested in is like how they solve these problems.
Yeah, let's see.
And then don't they I want to know, do they store it in different areas? Let me see.
What do you mean?
I was trying to like remember what I read earlier, like how they
I think they would physically store it. They probably have a separate physical
yeah, like a
server.
separate physical. Yeah, yeah, that's what I was thinking of. I just wanted to like verify and not just say it off the top of my head.
I'm pretty sure just because like we did a bunch of systems design work and it was like that's the type of thing that because you wouldn't use column storage unless you had like a shit ton of data,
Hmm.
you wouldn't use a data warehouse unless you had a shit. So you probably would want to have it in a separate database because just because like I think it's pretty common to split off based on utility, so you'd
Right.
have like read oriented database, like read replicas, databases that handle writes, probably a separate database that handles analytics because it's like long
Hmm.
reads. You wouldn't want to like clog up your transaction processing, which is processing a bunch of writes with these long reads. Um, I don't know. I think it's probably a separate.
Yeah.
Well, it has to be a separate thing. Actually, are you saying a separate
Well,
machine
it's
or at least?
in this section it says if each column is stored in a separate file, a query only needs to read and parse those columns that are used in that query, which can save a lot of work. So here it's a separate file, but I would imagine that you can come up with a bunch of different ways to do it. It could
Oh, are
be
you saying each column?
yeah. It says if each column is stored in a separate file, a query only needs to read and parse those columns that are used in that query.
Oh, I thought you were talking about the data warehouse as a whole. Yeah, the
I mean,
columns.
I was just saying, like, just in general, like,
Yeah, the
that's what,
columns are probably all on the same sheet. Yeah, that's a good point.
yeah.
Cool, cool.
Okay, here's another cool part. It says, besides only loading those columns from disks that are required for, blah, blah, blah. Besides only loading those columns from disks that are required for a query, we can further reduce the demands of the disk throughout by compressing the data. So I'm pretty sure there's like a lot of different ways to kind of set this up.
Oh, interesting. Interesting. Saying bitmap encoding. What's
I wonder how they would.
see this type
Do
of
you
stuff?
understand? Oh, go ahead.
I was just saying this type of stuff will be cool once we learn about computer architecture, which I think is
Yeah.
unless you're already taking a class about that or something. But when it talks about like this, I have no idea what they're talking about. But,
Oh, yeah, okay. I was gonna ask you more about bitmap encoding because I'm not like,
what's a bitmap?
that's what I was hoping you would know.
I mean, I'm assuming they're mapping values to bits, just like you do it with
Yeah.
enum. Like that's my guess. Is you'd have like a map. Yeah, it's probably just an enum associated with like the bit values. You know,
Right. Like, yeah, kind of like a, what am I thinking of? Like, like an array or something.
I would think it's just like you do like an enum, which is probably like a map to values. You know, so
Yeah.
instead of like hard coding in the string,
Yeah.
you're you're mapping the string to one specific bit, you know, if there's less than 255, or I don't know about, yeah. I don't know.
No, but I know where you're going. Like, I understand where you're going.
Yeah, but wouldn't the 255 thing be a byte, not a bit? Like a
I'm
bit
not
is just a
sure if they're
one
using
zero, right?
the
So
word bit in that same. Let me look. Let me read it.
because I thought they were already translating this into ones and zeros anyway.
Right.
Like I thought that was a part of the thing when they're storing stuff in memory. They're not storing strings in memory. They're like storing the bit, like the machine, the you know I thought they were already kind of doing this with memory.
Okay. Actually, this is exactly what it's doing. A bitmap is mapping some domain, for example, a range of integers to bits. So that makes sense.
But multiple bits. Let's see, bitmap for. Oh, um, interesting. I don't. Wait.
Oh, I think I get it now.
Are they just saying that? I think they were just saying there's like maybe 100, there's like 100 different values that could be true or false.
Hmm.
I could be wrong, but like, yeah, and it's very small. 200 distinct values.
I guess what I don't understand is what makes this more efficient? Like what makes this efficient? You know what I mean? Why was this their answer? You know
I
what I
would
mean?
think instead of 200 lines or instead of 200, let's see, because they're saying billions of transactions, 100,000. Yeah, so we have a column with n distinct values.
Hmm.
Um,
Okay, I guess it's okay.
so it would
Okay,
be
I think
like
this makes a lot. Okay, this is
United
starting to make
States.
a lot of
It's
sense.
just it's just saying instead of having to store, isn't it? Wait,
I let me just read this a little bit more, but I think this makes a lot of sense. I need to collect my thoughts.
okay.
Okay. I guess because my answer was the bits are like smaller units information to store as opposed to whatever it was originally, right? Depending on the data in the column, different compression techniques can be used. One technique that is particularly effective in data warehouses is bitmap encoding. Often the number of distinct values in a column is small compared to the number of rows, blah, blah, blah. We can now take a column with n distinct values and turn it into n separate bitmaps, one bitmap for each distinct value, with one bit for each row. The bit is one if a row has that value and zero if not.
Hmm.
Yo, this is crazy.
What?
Just this whole concept.
So let's just walk through this example. Yeah, I mean,
Yeah, let's
if
go
you
for it.
actually care about this, because I don't quite understand it. So it's saying common value column values, right? Is
Hmm.
let's say there's something with a bunch of what is it saying? Products, SKUs, right? And so it's saying like as if this is a normal database, right? This would just be one column. Let's say
Right.
there's 100,000, items or something. with 100 product SKUs and there's some random thing, or we could even make it simple, like if, let's say there's 50 items with 10 product SKUs or something.
Right.
And so that's there. You just take that column, you flip it on its side, and it's now a row.
Hmm.
And how is this working for column storage normally without bitmaps? Once you take it and throw it on a row, what do the columns consist of then? What are the row and column? You know what I mean?
Yeah.
Or sorry, what are the so each one has its own columns. What do the rows consist of?
Well, that's a good question. Because I guess the way I was thinking about it was that if you look at the column values 69, 69, 74, 31, or whatever, a lot of this is like duplicated, right? So instead of just copying a bunch of duplicated values, you just create this one bitmap to where it's like you only have like the one and a bunch of zeros. So you just have that as opposed to like storing all of these different numbers, right?
Mm, hmm. But what would
You don't,
just the first part? I guess I'm just not, now that I'm thinking about it, I'm not understanding what a column or column storage layout is in general. Like this is a column storage here.
right.
So this to me just looks like a regular table.
Oh, we're looking at two different examples. I think are you looking at
Oh,
figure
here we go.
10?
Column. So this is a regular table. Um, column storage layout would be,
What figure are you looking at?
oh, you can see yeah, 3-10.
3-10. All right. 'Cause I was looking at 3-11.
So storing, I was just thinking about it. I'm like, I just want to make sure. But here's my question. So is it literally just like a column oriented store is it's just like a key value store essentially? Like it's just like, okay, here's the ID and here's the uh
That's yeah, that's what I thought.
and
I thought it was
here's the value associated, the column value associated with it.
yeah, I thought it was taking that value and then giving it like you're just taking like the I don't know if index is the right word, but hold on, let me read this one more time. I guess because I'm thinking that it's
So this is the value from row one.
right,
This is the value from row one. This is the value from row one. Okay. Row one, row one. So this is just row one, right?
right.
Uh, I don't know. I'm just having a little trouble picturing what this actually looks. So like this is a table, right?
So what I guess what I'm thinking is okay, so we see the column values, right? Of let me go back to the figure. It's six product SKU 69, 69, 69, 74, 31, 31, 30, 31, right? Even though there's like 9 of these values, there's actually only 3 distinct ones. So it's actually only 3 values that we actually have to remember. So instead of taking this this integer 69, we'll just give it like the marker of the number of bits it represents. And we just save that bit. And then
So
go ahead.
so they're just saying it's an enum, basically.
Yeah,
Okay, so we got back to okay, so now I think it's making a little more sense. So it's just saying, yeah, it is just a table that's going to consist of basically episode ID or whatever it is, or like not episode ID, sorry, like the ID from whatever the core table is, right?
right. Yeah,
And then here it might not even have the ID, it might just be array. It looks like it doesn't have like how it's actually stored is it's not going to have an ID, it's just going to have like number one, number two, number three, number four, whatever.
yeah.
So okay, yeah, that's cool. So then I guess when you're loading that attribute, you're just loading like the first, like if you were to run a query, you would load up like, okay, I'm looking for a product, um, all like let's say like all products with product SKU number 100.
Mm,
Then it would go in and the what's gonna how does that actually work? So there's the
gotcha.
parent column or whatever, or right, so I guess you'd read from the parent. um I mean, I guess let's say you have 100 total products, right, and you're looking for products with product SKU number 10 or something. So you look and
Hmm.
you read the first one in that just list of products, and you see, okay, this doesn't have um well, how would they even be able to tell, actually?
Interesting. Hold on.
It's probably an index or something.
Yeah,
Um, maybe an index, but if they're reading one after the other, wouldn't they need to? Oh, they wouldn't be able to tell. They would have to actually do this for every single item,
right.
right? But the difference is they don't need to load 100 or a thousand lines. They just need to do one. So it's okay. Item one. Okay, we need you know to check this other table here. Let's load that information. Is it correct? No. Let's throw it away. Okay. Item
Right.
two. Where's the foreign key or whatever? Not a technical foreign key, but it's probably where does this correspond? Okay, cool. This one works. But then what's the problem with just storing? Like, this is a pretty small amount of data, no? Like,
Well,
I'm just
because
saying,
I
I
think,
look at this. Maybe I'm just not I look at this, and what looks bigger?
well, I think it's because the way, like, say the number 69 would be saved is different from the way this bitmap is. You know what I mean? It's just a smaller unit of information that's used to compare, like, I mean, used to like represent a larger one.
So you're saying the 69 would be, let's say, a 32-bit integer or something like that.
Yeah, that's what I'm imagining. It's
Or
like,
a string would be multiple
yeah,
16-bit. Yeah, that's a good point.
yeah. I was trying to find like the right like vocabulary for it, but you know what I'm trying to get to.
Yeah, I get, because I guess you're right. It doesn't need to be that much larger. It could be like, let's say you have 10. How big is a string letter typically? Is it 32
So
bits?
like, yeah, we'll just see.
So yeah, it could be 320 bits
Right,
versus literally 16, bits. And
exactly.
16 bits, and you've got how many, like what is that? Is 255 one byte, or
I don't remember like the math,
yeah, I don't remember. Yeah, I
but
think but yeah, so
but
literally
it
one
says
byte.
an unsigned char would be 8 bits, right? So I'm sure like
I think it can
whatever.
go up to, I think some languages it's 32 or 16 or something. Yeah.
Yeah, let's see.
Oh,
Yeah,
and I guess
because
you actually don't even necessarily need the 255, right? You could just, like, let's say you have three options, you could just make it I think
right, and if you're saving it,
right?
like it just says like an unsigned integer is 16 bits. So if you just converted that integer into like to this bitmap, that's only gonna be like how you know what I mean?
Yeah, especially if
It's
you
gonna
have
be way
four
smaller.
options or something. Four
Y-
options and you have 3 bits, 4 bits.
So you're like, yeah, exactly.
Because
So
that
it
would
would
be
be
eight.
16 times however many times you got, you know what I mean?
Yep.
It would so you would quickly like run out of space.
It's by the way, 256 is one byte. I was
Right.
wrong.
Not okay.
But cool. Yeah, sounds
Yeah.
good. Sounds good. Yeah, that is pretty cool actually. You're right. I guess you could like it's like a 10x improvement, you know.
Yeah. Like
Or
because
I
if you
guess
had
improvement's
because if it
pretty
was 16
pretty
bits
cool.
for one number, yeah. So if you had like you had 69 four times already, so that's already like what 16 times four is like what 64. So that's already 64 bits. But if you had just saved it once, it's like I don't know how many bits that would be in just that one bitmap, but it would be like way smaller than 64.
Well,
You
I
know what I
think it
mean?
would be based on the number of possible value. That's what I'm saying. Like, because you could save one bitmap value
Right.
per thing. So for 1 byte, 8 bits, you could have 255 values, you know?
Exactly.
And if you, because it's just a bit's just one binary thing, you know? So if
Yeah.
you only had 2 options, if it was just true or false, you should be able to make that fit on one bit, right?
Yeah. Yeah. Exactly.
So that's cool. Yeah. So it's just like a Eno, like low level Eno,
Yeah.
basically. And then it's saying it can go even it can be compressed even further, right?
Yeah. I was just rereading that. Let
What
me
was it
see.
saying? It was saying something like
It can be additionally runless coded.
as shown at the bottom of figure 311.
Yeah. So it just counts the zeros. 1 1 9 zeros 1 1 rest zeros.
Uh
That's cool.
oh,
That's actually really cool.
that is pretty cool. Yeah, because each one of these is just I would think, I mean, I guess you could have multiple stored, but yeah, that's super interesting.
Yeah, that's actually really interesting.
So how much would that save, do you think?
Let me see.
Hmm. So that's compression for you.
Yeah, it's actually I had no
That's
idea
like
compression was this interesting.
legit compression.
Yeah.
That's just how it works. That's cool. I think that's also kind of encoding, right?
Yeah, runless encoding.
Or so what is it like? Uh the serializing, deserializing.
Yeah.